Okay, so I'm going to do the homework from number 3 for this class to give you an idea of the methodology of what I'm doing, my thought process as I'm going through these problems. So problem 1, a study was conducted by any town college to determine how often students visited the library on campus during a given semester. 500 students were surveyed and the data collected is presented in the table below. So this is the table. So 500 is our total, and that's also n. It's our sample size. All right, so probability. Remember the probability of an event equals the number of successes over n. So that's just a general probability formula. Now let's see. Part A, determine the probability a randomly selected individual visited the library over 8 times. So more than 8. More than 8 is, well, 9 is more than 8. So, and this is only one column, so 206 over that 500. So, and I wrote it like probability that either x is greater than 8, which is the same thing as probability that x is greater than or equal to 9, and I'm going to let x be the number of times. Number of visits, we'll say, number of visits. That's what we've got in the problems. We'll change to that. Okay, and then I'm going to use M for male and F for female that I've got right there. So, but anyway, x is greater than or equal to 9 or x is greater than 8. They're equivalent statements here. And that simply equals that 206 over 500, which if you want to do it on the calculator, 206 divided by 500 is 0.412. And that is how you do part A, and that's just a basic general probability question. Part B gives us a little bit extra meat to it. They want the probability that the individual visits the library between 3 and 8 times inclusive. So let's talk about this word inclusive. If you don't know what it is, certainly Google can be your friend for something like that, or an email to me will work. However, inclusive means we include those numbers. So we'll use the equal to sign as opposed to just greater than or less than. So we want probability that our value is between 3 and 8. Inclusive means the equal to sign part of this. And so let me do some erasing up here. Okay. 3 to 8. So we have this 3 to 5 and then 6 to 8. Those two will be what we need. So this is simply 100 plus 84 over 500. We're still talking about the whole sample. And that's 184 over 500, which we can calculate here. We have 0.368. All right, part C, we want the probability a randomly selected individual did not visit the library 2 or less times. So not 2 or less. Okay. Well, if it's not 2 or less, we can use the complement rule that we learned, which is probably the easiest thing, or we can just add up all the others. So not 2 or less means the areas we want are 3 to 5, 6 to 8, and 9 or more. So we can do this in one of two ways. We can either just take, probability that x is greater than or equal to 3 is going to be 100 plus 84 plus 206 over 500. Or we can take 1 minus the probability that x is less than or equal to 2, which is 1 minus 110 over 500. And I'm going to skip the calculator for some of these. I've already posted the numbers online, so you'll at least have those. D, determine the probability that a randomly selected individual is female and visited the library at least 6 times. So, and, let's highlight that word and. And means intersection. That means both of them have to occur at the same time. Well, 6 or more are these two. We've got those 2 rows, and we're looking for female. So this column, those intersect at this 23 and 126. So how we could do notation, probability that we have a female and the value of x is 6 plus. And if you want to do x is greater than equal to 6, as well as that works. I'm just going to use this as far as notation. So we know it's going to be 23 plus 126 all over the 500, whatever that equals. All right, E, determine the probability a randomly selected individual is male or visited the library at most 8 times. So let's do this. And okay, so or is a union. Or this symbol here, the upside down, or the U, I guess the intersection is the upside down U. Okay, so we can use our additive rule of probability for this. That's typically the way I go, or we can just highlight all of these values. So we're looking for male or 8 or more. So the males are all of these, or we can just highlight the 230, but I'm going to do this for right now. Or at, excuse me, it says at most 8 times. So at most means that much or fewer. So it's going to be all of those. So we could just take our total of 500 and subtract 126. I'm going to do let's see. So we want probability of male, we want or, and I guess we'll just do x is less than or equal to 8. All right, and you can do this in the additive rule, which probability of male, which we know to be 230 over 500, plus the probability that we're less than 8. And I don't have that anywhere above, so less than or equal to 8 will be 110 plus 100 plus 84 over 500. And then we have to subtract the intersection. And let's stretch this out a little bit here. I'm going to use a calculator. So the intersection, probability of male, intersect, x is less than or equal to 8. So what do we have there? I'm going to do another color. The intersection are those, right? So what do we have here? 35 and 54 and 61. Oh, plus, excuse me. And that should be a minus here. So those are the calculations. And again, I've got the solutions on the actual upload of my work here. All right, let's take a look at F. Determine the probability a randomly selected individual made at most 5 trips to the library. At most is that many or fewer, just as it was before. Oh, I jumped down. No. I was reading the wrong thing. So F. Some probably a randomly selected individual made at most 5 trips. All right, so that's going to be this 100 and 110. So at most means that many or fewer. So this is just probability of, say, x less than or equal to 5. And then we have 110 plus 100 over 500. And again, clean that up to be whatever it's supposed to be. G, the probability a randomly selected individual is made at least 0 visits. Well, all of these people made at least 0 visits. At least is that many or more. So this is just 1. So it's either probability that x is greater than or equal to 0, which is 500 over 500, which is 1. That's all that is. H, and I'll scroll back up to the chart as needed. Look for the probability a randomly selected female did not exceed 5 trips. So did not exceed means less than or equal to. Right? But I want you to note this. A randomly selected female. This means we're ignoring all of the males. So typically if you've got a chart like this, what I would do simply is only take a look at the row or column of interest. Here we know that it's a female, right? So we're only looking at that. So our sample size is 270. So that is going to be our new N for this problem. Let's go back to the question here. Did not exceed 5, so 5 or less. So we're looking specifically at those two. So we're going to add 75 to 46, but divide by the 270. And our notation for this, probability that we have a value less than or equal to 5, this vertical line is the word given, we have a female. And so we noted 75 and 46 were the numbers, and 270 is our new N, and whatever that comes out to be. So that's something you want to look at. If you already know the person's a female, you can ignore all the males. You're not dealing with 500 anymore. You can also use the formula for the conditional, which is just fine as well. And that's actually preferable if you don't have a nice chart like this. You can't eliminate everything. All right, so I determine the probability a randomly selected individual, so anybody, male or female, visited the library at least 6 times. So this is going to be probability that x is greater than or equal to 6, which, let's clean up some of this stuff here. Again, greater than or equal to 6 are these two, so it's just going to be the total of those two over 500. So we have 84 and 206, 500. And that equals what it equals. J, determine the probability that a randomly selected individual visited the library at least 9 times or was male. So we have an or here. So that's the unions. We want probability that x is greater than or equal to 9. Union, the person was male. So our additive rule means probability that x is greater than or equal to 9 plus the probability that we have a male minus their intersection. and greater than or equal to 9. So greater than or equal to 9 is simply this 206. Male is this 230, and then their intersection is 80, which is what we're going to be subtracting off. So this equals probability that X, oh, I already have those. Let's just put in the numbers. So we had 206, and the male was 230, I think. 230 for males. And their intersection was 80. That shouldn't say equal, that should say minus. And then that equals whatever it equals. All right, then we have K, determine that the probability a randomly selected individual who visited the library between 6 and 8 times. So we have another known. We know this person visited between 6 and 8 times. Inclusive, again, we've seen this definition, was also male. So we're only going to look at the 6 to 8. So we're going to ignore, I did the wrong one. We're going to ignore everything but this highlighted section here. We're only looking at the individuals who were there 6 to 8 times. So our new N is 84. Well, of those, which ones were male? Well, that's simply 61. So that's going to be 61 over 84. And let me give you some notation. This is the probability that we're going to have a male, given that we already know they were there between 6 and 8 times. And we determined that to be 61 out of 84. And I think I did the actual formula for it. The intersection of the two things over the probability of the second one. But either way it comes out to this. It's nice and easy with a chart. And our last one on this problem, and I think I'll cut it after this and I'll make another video for the other ones. Determine the probability that a randomly selected female visited the library at most 5 times. So here we go. We have another conditional, randomly selected female. So our notation for this will be probability at most. That means less than or equal to. So X is less than or equal to 5, given female. So we know it, the individual is female. So we're only looking at the females, only this one, only this group here. Ignore the outside, so no and no. And we want less than or equal to 5. So less than or equal to 5 would be these guys here. So we're going to add 75 to 46 and put them over to 70. And we figure out the decimal or other fraction for that. So I'm going to do another video to conclude this homework.